Welcome back, chemistry fans. What we're going to try and accomplish today is, I believe it may be one of the parts of the types of reactions. So far we've seen some synthesis, we've seen decomposition, we have seen a single replacement, we've seen neutralization, but we're going to hopefully now get ourselves into a double replacement reaction. So let me change and we will get started here. Let me switch. Okay. And so it is correct. So we'll put this in here so that you can see what we're working with. All right. So now what I'm going to do is I'm going to take my sodium sulfate. I'm going to just add a little bit into my cup. Hold on, first off. We're just going to add a little bit of water to this, nothing special. We're going to add just a dash of sodium sulfate. Put that in there. And it's aqueous solution, or it's an aqueous material, so it's ionic. It's going to dissolve nicely. And so you notice, look, there's nothing left of that powder. It's all dissolved into our compound nicely. And so what we're going to do next, though, is we're going to take barium chloride. And so what we're going to have is a double replacement reaction. So again, I'll take just probably an equal amount of that same type of material. I will add it in, and instantly what you start to see is that there's a reaction that we are starting to replace, and we are making ourselves barium sulfate and sodium chloride. So the salt would be dissolving, and the other one would be forming this white substance here that makes it look basically like a milky white substance. All right, so that's all we needed to recognize, is that that is a double replacement reaction for us. Next, what we're going to do is a combustion reaction. And in a combustion reaction, this is actually flammability, but it's the same concept. I'm just going to take a little bit of ethanol. Ethanol is very, very dangerous. We cannot leave the vapors open for very long. So I'm just going to suck out just a small amount of my ethanol into my pipette here. And then I'm going to recap my ethanol, remove it away from the flame so that we are not a hazard anyway. And then I'm just going to put in a few drops here. And what you should be able to see, hopefully, if I take this down from the edge, is you're going to be able to see the flame on this material. And I'm going to turn off the lights for this one as well so that you can witness it firsthand. I am going to ignite a stick here. Just a little splint. And we're just going to touch it to the ethanol. And you should then start to see those flames go. And so what's going to happen here is it's combined the oxygen with the ethanol to make a carbon dioxide and water product. I'm just going to let this burn out. I'm not going to try and attempt to put it out with anything. With water would not help us with this scenario. But as it starts to fade, there it goes. What I'm hopeful that we will be able to see at the end is that there is a little bit, just a little drip of water residue down in here. It's hard to tell in the dark. Let me see if I can turn on my light. And what you'll notice is that, yeah, there is just a little bit of water residue in here after it's left over. And that is one of the products of our combustion reaction that we had with the ethanol. All right, last reaction. What we're going to do is we're going to start with a test tube rack. I'm going to take this again from the side. And we've got a test tube rack, and in this test tube rack, what I'm going to do is I'm going to put in just a few samples of zinc metal. So zinc metal, nothing special about the zinc metal. It's just, it looks brown, or it looks gray and silver. And so we're just going to put in a few choice pieces that are a little bit smaller. We don't want these big pieces because it would take it a very long time to react. And then I'm going to put into that then an HCl. And what that HCl is going to do is it's going to trade places, a single replacement reaction with the, it's going to trade places HCl with the zinc, and it's going to then release the hydrogen and allow it, it's going to allow the HCl to form a hydrogen gas? Well, once we've started to bubble there, we want to capture that. So I'm now going to put a second test tube on top. And so that's what I've got going right there. I am capturing that. So there's ways that hydrogen can leak, but the hydrogen is lighter than air, so it's going to be floating up. So we're just going to hold this here for about a good minute and allow this to capture. And then while that goes on, I am going to light that same wooden stick and I will touch it to the bottom, and we should hear evidence that we have captured hydrogen gas. Hydrogen gas is combustible. It blows up essentially, whereas the ethanol was flammable, but both of them are using oxygen. It's just a subtle difference between their definitions. So I'm going to move my camera. You can see I'm still forming a lot of hydrogen gas down here at the bottom. I just got to be careful not to jostle it too much so I don't create too much of a place where the hydrogen gas won't form. So I'm going to go ahead and I'm going to light my stick. And then I'm going to move it off to the side. And then I'm going to touch it to the bottom of this test tube. And that's going to allow for the combustion to occur. And then hopefully you got to see that in slow motion. So thank you very much. This is everything that I wish to share with you today about our different types of, whoops, wrong way, our different types of reactions. Thank you so much for paying attention. Hopefully now you have all the different versions. Bye-bye.